Improved composites for aerospace, land, and sea using aligned nanoforce technologies, or ANT. This is topic Navy 201-072, performed for the Office of Naval Research, and I am Dr. Bill Goodman, CEO and CTO of Goodman Technologies. GT was established July 2016. It was 30 days after learning my 13-year-old boy needed heart surgery and a week after being laid off. And just like you and your mission, I knew that I couldn't fail. We are business to business and business to government company. We perform R&D and manufacturing as a service in commercial space, aerospace, and defense markets. Our registered trademark GT nanomaterials and processes are compatible with additive robotic manufacturing, and we make nanocomposites for the most extreme environments. We have a rich technical history, almost 9 million in competed SBIR, STTR awards, 4 New Mexico Small Business Assistance grants. We've had a phase 3 transition with the Navy System Prime off of phase 1 contract. We have a rich patent portfolio. Our key resources are our people and advisors. We have a former chief scientist from AFRL, Dr. Paul McManaman, a former chief scientist from the Space Force, Dr. Tom Cooley, and a Distinguished Service Award winner from the NRO, Dr. Ken Summers. We have an established nano laboratory in Reno. We do cradle-to-grave design, analysis, manufacturing. We do thermal, structural dynamics, electromagnetics, optical and radiation design and analysis. We perform nanoceramic printing, microwave firing. We have a hot press, 3D scanning, and large-scale robotic manufacturing is part of our portfolio. We have many achievements, and we have a legacy of flight demonstrations, including a TRL-9 system. The objective of the Navy topic is to demonstrate increased performance of polymer matrix laminate composites using nanoscale additives. The problem with current high temperature polymers is that they have a very limited amount of interlaminar shear strength. The solution is aligned carbon nanotubes in between the layers of composites. This will increase the interlaminar shear strength, the toughness, and the fatigue capability. The aligned carbon nanotubes relax the need to increase thickness and corner radii in high temperature polymer systems. There are several technology areas: air platforms, materials and processes, and weapons. There are several acquisition programs: PMA 265, the Joint Program Office for the F-35, and Next Generation Air Dominance. The requirement is to make the higher glass transition temperature, AFR P4, at least equal to or better than Hexcel 8552. And it's desired to demonstrate dramatic improvement of the interlaminar shear strength of this commercial product. The Navy asked GT to improve the orthogonal properties of high temperature composites using our ANT technology. These are aligned nanoforest technologies. The beneficiaries are the system primes that make aircraft engines as well as aircraft structures. So Raytheon, GE Aerospace, Lockheed Martin, Boeing. There are multiple transition targets: the F-14, the Growler, and the F-35. There are a number of other transition opportunities across the fleet, including prompt strike and hypersonics. There are also applications for waterways, and those are landing craft, ship-to-shore connectors, the masts on ships, and deck houses. GT Nano ANT technology has demonstrated double to triple digit performance increases in fracture toughness for the sighted composite systems. Multifunctional, multi-directional nanoforested composites. GT has demonstrated technology to drastically improve the orthogonal properties in laminate composites. We're the first on the planet to demonstrate an orthogonal nanoforest technology, and this is key for a variety of composite prepregs in use by the Navy today. GT's demonstrated double to triple digit performance improvements for Navy relevant epoxies, bismuth imides, and polyimides. And our ONT or ONT technology behaves like nano Velcro to improve the mechanical and thermal properties of laminate composites. Current status of the project, back in Q2 of 2022, we started growing our ONT technology. We optimized it by Q1 of 2023. We started manufacturing it and produced panels for our Mega Matrix starting in Q2 and Q3 of 2023. We then demonstrated our aligned nanoforce technologies with T650 and Bismally imids and started preparation for Mega Matrix testing towards the end of 2023. In late 2023 and early 2024, we'll produce AFR PE4 panels and do a prototype demonstration with a system prime, at which we will exit with a TRL6 and be ready for a phase 2 option. We'll be ready for several programs of record across the fleet. The key features, advantage, and benefits of GT Nano materials are this. We provide a high temperature composite solution for the fleet. We can reduce scrap, rework, and repair, which in turn reduces sustainment cost. We've demonstrated 45 to 120% increases in mode 1 fracture toughness for commercially available products already. This enables lighter, tougher, stronger, dimensionally stable aircraft engines and structures. It allows more fuel efficient and longer range aircraft, and it also provides a low observable technology for aircraft, drones, ships, and spacecraft systems. To transition to the fleet beyond phase 2, we'll need to complete our Mega Matrix testing, collaborate with engine and airframe system primes to build and test prototypes. GT is actively seeking scale-up funding for government and commercial applications. GT and the Office of Naval Research are seeking a transition advocate. Our composites have applications in air, sea, space, and land domains. GT may have available 3-to-1 leverage from the Office of Strategic Capital. By March of 2024, we'll have a detailed materials properties database for several composite systems, and we'll have demonstrated our first relevant engine prototype. GT has had 25 business schools and a national laboratory do market analysis for us, and we've realized many dual-use commercial applications for air, space, land, and sea domains. Our GT nanoforce provide multi-directional, multifunctional composite improvements. Our technology works with the vast majority of composite systems, including epoxies, polyimides, ceramic matrix composites, carbon-carbon, Bismally imides. It works with the vast majority of composite manufacturing processes, such as vacuum-assisted resin transfer molding. Our technology provides Navy and DoD cross-enterprise solutions for composites used in aircrafts and missiles, ships, turbine blades, spacecraft and CubeSats, drones, electromagnetic and weapons effect shielding, thermal protection systems, and hot structures. GT has an immediate need to transition our technology to program offices, primes, and commercial customers. Our aligned nanoforce technologies and nanoresins are compatible with a majority of manufacturing processes, including additive and robotic, and for composite systems ranging from polymers to ceramics and even carbon-carbon. We've demonstrated double to triple digit performance improvements from addition of our materials. We have applications for air, sea, space, and land domains. The result is lighter, stronger, and tougher nanocomposites with improved laminar shear strength, which can survive extreme environments such as hypersonics, deep cryogenic, space, and man-made radiation. Aircraft become lighter, more fuel efficient with greater range, can be low observable. Spacecraft are lighter, more dimensionally stable and survivable. Dimensional tolerances are increased. This reduces scrap, rework, repair, and sustainment costs for users. Thank you for your time and attention, and remember this: when you need nanocomposites for extreme environments, you better call Goodman. Dr. Bill Goodman will be at the STP Air, sea, and space.